Now, for you to understand more, let us have here an example of adding vectors using their components. So, three players on a reality TV show are brought together to the center of a large flat field. You can imagine yourself as one of these players of the reality TV show. Now, each is given a meter stick, a compass, a calculator, a shovel, and in different order for each contestant, the following three displacements. So you have your vector A, 72.4 meters, 32 degrees east of north. Your vector B, 57.3 meters, 36 degrees south of west. And then your vector C, 17.8 meters due south. So again, the three players were given these three vectors in different orders. So let's say as the first player, you're given the order A, B, C, and then the second player was given the order B, A, C, and then the third player was given the order C, B, and then A. Now, the three displacements led to the point in the field where the keys to a new Porsche are buried. So this is actually a treasure hunt. Okay. The two players start measuring immediately. So your competitors, players number 2 and number 3, immediately measured 57.3 meters using their meter stick, and the other immediately measured 17.8 meters due south using his own meter stick. And imagine that is very much time consuming because you're going to measure very long distances. You have 72.4 meters, 57.3 meters, and then 17.8 meters. So let's look at player B. So he gets his meter stick and then measures 1, 2, 3 up to 57.3 meters. Okay. But the winner, which let us say is you, first calculates where to go. Okay. So again, the winner first calculates where to go. So why did you do it? You did it because you know that the displacement will just lead to the same point, and that displacement is the vector sum of your three uh, vector displacements, right? So if you're going to calculate the vector where you're going to go, you're just going to measure one vector and you win. Otherwise, if you're going to measure your A vector first plus your B vector and then your C vector, you will have too much time to take going to the treasure or going to where the new Porsche keys are buried. So calculate where to go. Okay. Okay. So let us now calculate the resultant displacement or the resultant vector in which the winning player calculated in order to find where the keys to the new Porsche is located. And we have here a diagram of where we estimated that vector R is. Earlier, we assumed that as the first player, you were given the magnitude or the order of the vectors A, B, and C. If you're going to draw it manually in diagrams, this is how your vectors will look like. So first you draw your vector A, 72.4 meters, 32 degrees east of north, and then after reaching your 72.4 meters, you make a turn with your vector B of length 57.3 meters, and then finally you go downwards with your vector C, 17.8 meters. Now imagine if this is a real life scenario and you're going to measure these three vectors here. So this is of course a very tiring job as these are very long lengths. Okay, so in order to win, since you know already that you just need to find the resultant vector or the resultant displacement so that your life will be easier, we wanted to know what this vector is, your vector R. Okay, now let us solve this one using your component method. Okay, but The first step that I suggest to students to do is you draw a or you make a table wherein you can put all your calculations to summarize all your calculations. Okay, like say for example this table here, you have a column for your vectors, your x component, and then your y components. So let us start solving. Uh, the order of finding the components of the vector here does not anymore matter. But suppose let us say that I want to start with your vector A. Okay, so I wanted to start with vector A. But let me just redraw your vector A here. Okay, your vector A is 72.4 meters. And then you have here your angle 32.0 degrees. This is your vector A. So let us project this one onto the x and y axis. So projecting your vector on the x-axis, this is here our ax. Projecting along the y-axis, we have here our ay. Okay. And always remember that if you're going to use our previous formulas, you have to look at the location of your angle. Looking at this one here, you see that your angle here is drawn from the north towards the east at 30 degrees. So with respect to this angle here, your AY is now an adjacent side and your AX is the opposite side. Okay? So you do not immediately use the formulas that we had earlier, but instead you should always look at where your angles are located. But if you find this one a little confusing, we can always use this angle here, okay? Remembering that this is at 90 degrees. So if you want to use this angle here, this is just 58 degrees. So that your AX is the adjacent side and then your AY is the opposite side. But regardless of what angle you're going to use, you should get the same answers for your X and Y components. So let us now solve this problem. Okay, let's first find the X component of your vector A. So since your X component is the adjacent side, I can use your A cosine theta. Your A is 72.4 meters, magnitude of A, times cosine theta, which is 58 degrees. Okay, using your calculator, we get an answer of 38.37 meters. Okay, if you want to use again your 32 degrees, since your AX is at the opposite side, you can use this one. Your AX is equal to A, since this is now the opposite of A sine theta. So you have 72.4 meters sine 32 degrees. Okay, you should just get the same answer of 38.37 meters. So we have our AX, which is equal to 38.37. So let me write this one in our table. So our AX is equal to 38.37 meters. Okay, so you can pause this video to review the solution. Now let us calculate the y component of your vector. Let me just erase the writings here. Okay. Solving for the y component, you have your AY. If I want to use the 58 degrees, your AY is at the opposite side. So you have your A sine 58. or you have 72.4 meters sine 58 degrees. Using your calculator, we get an AY of equal to 61.40 meters. Or again, let's just solve it using your 32 degrees. Your AY is equal to, since your AY now is at the opposite side, you have your A, or at the adjacent side, you have your A cosine theta. So we have 72.4 meters cosine 32 degrees. And we should still get the same answer of 61.40 meters. So let me write this one in our table. Our AY is equal to 61.40 meters. Now, these are your AX and AY components. So we have already our X and Y components for your vector A. Now, let us proceed to our vector B. Let me erase first the writings here. Okay. We also use the same process. We project your B onto the X and Y components and then find the BX and then your BY. But again, as what I have did earlier, let me draw again your vector B. If this is the origin of your vector B, okay, and if I draw another X and Y plane, okay, you will see that your vector B is at the third quadrant, right? So let me draw your vector B like this at the third quadrant, okay? So here, and then your vector B is 57.3 meters, and then at an angle of 36 degrees. Okay, so projecting your B on the x-axis here, we have here our bx, and then projecting on the y-axis, you have your by. From here, you will know that your bx and then your by should be negative, right? Since your vector B is on the third quadrant of your xy plane, so your bx and then your by should be negative. Okay, your bx is adjacent side of 36 and then your by is at the opposite side, but they should be negative. If you want, we can use 0 to 6 degrees immediately, but you have to take note that we need to put the negative sign during our calculations. So your bx is equal to the negative of b cosine theta. Again, I put here the negative because I already know that your vector b has a negative x component. Otherwise, if you're not going to put that negative sign there and then you just immediately input your values, you will actually get a positive answer. But later, let us try to resolve that one. Let's just use here your 36 degrees in the meantime. So your bx is equal to the negative of 57.3 meters cosine 36 degrees. Your bx is equal to negative 46.36. Negative 46.36 meters. Okay. Another way to do it is by using your angle starting measured from your positive x-axis. That is, if I want to use this angle here, okay, so if I wanted to use that angle there, I have 180 degrees plus 36 degrees. If I wanted to use this angle, I have an angle of 216 degrees. Okay, well, this is actually nice, and I also um, I'd like to use this one often. Okay, when sometimes I feel that this is confusing. So I use the we can use your 216 degrees. So if I use the 216 degrees, we will just automatically use your b cosine theta, and then you have 57.3 meters cosine 216. Okay, your bx 57.3 cosine 216 will give you an answer of negative 46.36 meters. So you do not have to worry if you got the wrong sign for your component, because your angle here, your 216 degrees angle, will already give you that negative component of your bx. So we have our bx already. So let me put it on our table. So we have here now our vector b. So your bx is equal to negative 46.36 meters. Now, let us go to our by. Let's solve now here by using the same process. For your by, you can also still use your 36 degrees, or you can also use the angle that we have earlier, your 216 degrees. It should still give you the same answer. So let's solve your by. So your by here is at the opposite side. If I wanted to use your 36 degrees, I put first the negative sign. Okay, and then you have your b sine theta. So you have negative 57.3 meters sine 36 degrees. So using your calculator, you get an answer of negative 33.68 meters. Or you can, if you want to use your 216 degrees, use your b sine theta. You have 57.3 meters sine 216, and then we automatically get a negative 33.68 meters. Again, whatever angle you are going to use in your problem solving, you should get the same answer, because you just have the same vector that you're calculating. Let me put it on our table. Your by is equal to negative 33.68 meters. Okay. Finally, we get to the point where we are now going to get the x and y components of your last vector, your vector c. But this is just easy, right? Okay. Your vector c is just directed towards the south, so it goes downwards in your xy plane. If you're going to draw here, if this is the at the origin, you're going to draw an xy plane here. You will see that your vector c is just at the or just has the y component. So you can automatically put our answers here. Your vector c, since it has only the y component, your cx is equal to 0, and then your cy is equal to negative 17.8 meters, right? Downwards. So it's a negative. Well, to prove that it's really 0, because some of you might be curious if it indeed has 0 component in the x, and then negative 17.8 meters in the y component, We can also solve that one just to show some solutions. Let me use this angle here. Look at this angle here. Okay, from here to here. So that is 270 degrees. Okay, that is 270 degrees. Your CX is equal to a cosine theta. You have 17.8 meters cosine 270. Your cosine 270 is a 0. Sorry. So you have your Cx is equal to 0. And then your Cy is just a sine theta. This is 17.8 meters sine 270. Your sine 270 is negative 1. You have your Cy is negative 17.8 meters. But you don't actually need to solve this one anymore because it's obvious. This is just to show you that your Cx is indeed 0 and then your Cy is negative 17.8 meters. Okay, so let me put this one again in, or let me just erase this one for a while. We already have our your AX, your AY, your BX, your BY, and then your CX, and then your CY. Now you are ready to find the resultant vector R here. Okay, for your R is just equal to the sum of your X components. Your Rx is just equal to the sum of your X components. That is, your Rx is equal to the sum of your X components, and then your Ry is just equal to the sum of your Y components. So your Rx, this is equal to 38.37 meters plus negative 46.36 meters plus 0. So your Rx is equal to negative let's say you have negative 0.800 meters. And then your Ry is just the sum of your Y components. So your Ry is equal to 61.40 meters plus negative 33.68 plus negative 17.8 meters. Your Ry is equal to 9.92 meters. So these are our Rx and then the Ry. Okay, so you have a negative Rx, which is looking at your resultant vector. It is indeed negative. You should have negative component, and then your Ry should be positive. So we are right here. Okay, we are right with our drawings. Let me write it here. So your Rx is equal to negative 8 meters, and then your Ry is equal to 9.92 meters. Now, what is the magnitude of your vector R? Because what I wanted is the vector notation for your answers. So the magnitude of your R is just from your Pythagorean theorem. That is just your Rx squared plus your Ry squared. And then you get the square root of that. So you have your R is equal to negative 8 meters squared plus 9.92 meters squared. Okay, and then we get the square root. Your r is equal to 12.7 meters. So that is the magnitude of your vector r. And for your theta, for your angle, you have your tangent inverse of ry over rx. So you have tangent inverse of 9.92 meters divided by negative 8.00 meters. And then for that, you have tangent inverse of, again, 9.92 divided by 8, negative 8. So you will get an answer of negative 51.1. You have negative 51 degrees. But what's negative 51 degrees? So if you get that one, your negative 51 degrees is this angle here. Looking at the figure, since that is a negative, meaning it is measured from your negative x-axis. So your negative 51 is just actually this angle here. This is your negative 51. In order, there's another way of, there's, if you wanted to measure the angle from your positive x towards here, if you wanted this angle here, your theta here, you just have your 180 degrees minus 51. Okay. So since this is all at 180 degrees, so I just subtract your 51 with subtract 180 with 51, and then we get an answer of 129 degrees. Okay, you have your 129 degrees. There's we can also use this kind of solution. Let me show you another solution for your tangent theta. Let me just erase this one for a while. Okay, so we can also use this one. You have your theta equals tangent inverse, and then you get the absolute value of your ry over rx. Okay, we still get the same answer, but this time you have 51 degrees. But in looking at the directions, okay, remember again that this is your north, east, west, and south. So above your ry is positive, so you have north, and then your rx is negative, so you have your west. So your theta 51 degrees is measured from the north of west. So you have this one here. This is your north of west. Okay. So if you wanted again this angle theta, so your theta is equal to 180 degrees minus 51 degrees. So your theta now is 129 degrees measured from your positive x-axis. So this one here is 129 degrees. Okay. So finally, we have your vector r. So your vector r is equal to, or has a magnitude of 12.7 meters, 129 degrees, or you can also say 51 degrees north of west. So our final answer, okay, your vector r is 12.7 meters directed 51 degrees north of west, or your vector arc is 12.7 meters 129 degrees. Again, this is measured from the positive x-axis. Again, if this is your xy plane, if your angle is measured from your positive x and then you go counterclockwise, you have a positive. But if you go from here downwards, you have a clockwise direction, you get your negative. So counterclockwise is positive, clockwise is negative. So 129 degrees is here, from your east towards your west. So this is the summary of your calculations. So that's it for this video. On the next video, we're going to discuss on unit vectors, the unit vector notation, and then we go to multiplying vectors by scalar product and then vector product. Thank you.